Now let's try to apply energy balance equation to a closed system. Let's assume that the process is quasi-equilibrium, constant pressure process, and Q is coming into the system and W is done by the system, so going out of the system. We are going to use modern sign convention. We are applying Q as a positive value, W as a negative value. We don't have any mass flows into or out of the system. M dot in and M dot out is going to be 0. We are assuming that the system is stationary. So the change of kinetic energy and potential energy is going to be 0. So we can simplify the equation. Q minus W is equal to delta U. We are going to separate work done into two categories. 1. Boundary work. 2. Other work. So this other work can be shaft work or work to compress a spring, like in our previous example. I can write my boundary work in the form of P0 into delta V, because this is a constant pressure process. I'm going to take this P0 V2 minus V1 term to the right hand side and rewrite the equation. Since we know that H is equal to U plus PV, we can write Q minus W other is equal to enthalpy change. To further understand this concept, please follow the example 4.5 in your textbook, and the take home message is delta U plus boundary work is going to be delta H, change of enthalpy. It is extremely important to understand that this applies only if the pressure remains constant throughout the process.